Good morning, folks. Wow, holy crap, that was proactive, energetic even, enthusiastic nearly. All right, my name is Dean Wells, this is Jane Yan. We're going to talk to you about privileged access workstations this morning. I'm primarily here because Jane's technology that she's basically taken from inception through to this prototyping and incubation that we're about to show you, she's built it on top of something that I own, shielded virtual machines. So the reason I'm here is in case we get any of those questions. So that part said, before Jane takes you through everything about the privileged access workstation exercise that we've been going through with MSIT, I'd like to ask a quick question by show of hands. How many people here already have a privileged access workstation program? Oh, thank you. For 1 second I thought it was you, sir, and that was it. Okay, that was about 30 people, I would guess, in total. So not a particularly good percentage, given there's about, what, 1,200 of you in here? Okay, well, Jane's going to see if she can convince you to do a little bit better than that, but we had one final question. For those 30 that raised their hand a second ago, how many of you actually have to carry more than one physical machine to do that? Oh, you're going to love this then. All right, in which case I will hand it over to Jane without any further ado.
Thank you, Dean. Good morning. So, great. I'm really happy to see such a big crowd here. Privileged access workstation is such a big, broad area, and there's a lot to talk about. And given our time, I'm going to say it by a high level. If you do want to have an in-depth discussion, welcome to join me after the session, or we'll be at the booth under Windows Server Security and Identity. So look forward to talk to you. Quick going over the agenda. Since only 30 of you have privileged access workstations, I'd like to start with why is it important? Why is you need to think about to build it part of your security strategy? And then I'm going to show you some of the existing solutions, like some people here doing with the physical machines, and then turning around to see what we're doing with the privileged access workstation deployment inside Microsoft IT. At the end, I would like to share with you a proof of concept service, pulse service that we're building, and I would invite you to join us in this development journey. So for people who are new in the security field, this is a very simplified illustration of a very common attack. Here is a very typical corporate environment. At the bottom tier, you have all these user workstations and devices. And then you have the tier for the servers to providing the application services or managing the servers. And the top level there goes your domain controllers, where you want to put behind the locked doors, right? You don't want anybody unauthorized to go access it or touch it for whatever. Here's someone out of nowhere, and he is studying this corporation, this environment, using all the social networking knowledge to know about your users, org structures, everything about their interests, and the relationship between each other. Why? So he can craft this very enticing phishing email and start spamming your users. By the way, statistics shows that 90% of the breach starts with a phishing email. In this case, he did a good job, apparently, and someone got hooked up, fall for it, and sent the user accounts back to this guy through the link. And now what this guy can do is to connect to this desktop. And happen to be, this user also managed some of the servers on the second tier. And when that happens, more credentials get harvested by this person. And as it goes, eventually goes to your domain controllers. And once he get compromised the domain account, then he can basically touch everything, get everything, and then it's game over. So Microsoft has published a very comprehensive white paper to show various approaches that you can deploy in your environment to protect the domain controller or admin privilege accounts. And this is the white paper. It's a link. And here's a highlight of it. It's not intended for you to read every single item here. If you wanted to know the details, please go to the link. What I want to call out here are the bottom yellow 2 boxes. It's showing that privileged access workstation plays a major role in protecting your admin accounts. How? So let's go back to that attack scenario that we showed and take a closer look. This guy is able to go to compromise the admin account because one of the admins is using the same machine to do the productivity workload, like email or internet browsing, and using the very same device to manage the servers. So that whether it's a one account or separate account, they both stored on that machine. And so when this guy gets compromised one account, he can get access to that machine and then get other accounts. And also, because this machine is using productivity for productivity workload, many productivity applications require inbound connection. So Skype, for example, it just need to talk to this machine when you get a call. And also, the user needs to access internet to do the research, to do the work. So you cannot lock down this machine very much. And that increases the risk in exposing your admin account, which is exactly what Privileged Access Workstation is designed to protect. So what is Privileged Access Workstation? It's a concept, first, you want to separate the accounts. You want to separate the accounts that's used for your productivity workload, and then separately, you have a separate one for the admin workload, for the secure workload. And when you have those different identities now, and used for different workloads, now you can separate the workload to run in different machine context. And what's the benefit of that? Now you can lock down that machine that runs the secure workload. For example, you can harden the OS. You can whitelist the applications that's allowed to run on that machine. You can actually whitelist also the networking, saying that this machine can only access certain URLs or certain servers and block all inbound traffic. And now you are making that workstation a lot more secure compared to the desktop workstation. So this is a very deployment that we are recommending to our customers to do. And for those of you who raise your hand that who are carrying more than one devices for your administrators, this is a typical implementation of it, where you have one device that's dedicated to your desktop productivity workload and a separate one for your secure workload. That's what we call it as a privileged access workstation. In this model, your user have full control of and access to the desktop. They can do the internet, they can do the email on that desktop, and where on the PAL machine, you can give the user limited privilege on the physical machine itself. And also this machine can be locked down a lot more with like the application whitelisting and network whitelisting.
I have a question for the audience, if I may, Jane.
Yeah.
For those of you that didn't raise your hand, that you use physical access, rather privileged access workstations, how many of you use jump boxes? That's what I thought. That's more like 25% of the audience. So for those of you that have not raised your hand yet, what the heck are you using? Are you administering it from the same machine that you browse the web with? Go on, raise your hand if you're prepared to. Yeah, I know, the rest of you are doing it. Someone did. Okay. The reason I wanted to make this little statement here is because what doesn't get teased out in just talking about the way that we've done this, and Jane will get to it in a second, what happens if the machine that you're using as your desktop machine to RDP into the jump box, what happens if it has malware on it? Okay, well that malware typically can't propagate to the jump box. What if the malware is a keylogger? Well done. You still gave away the keys to the kingdom. Jump boxes are a great idea, but I think possibly they're rather a dying technology, or they're going to end up supplementing what we're doing here. That's just my opinion. We'll see how the industry takes it forward. But I wanted to mention that because I think it's an important differentiator, and Jane's going to explain to you why it is impossible for that to happen with the privileged access workstation.
That's a great point, actually, Dean, because there are customers that we talk to, and they think that they are using a privileged access workstation by either RDP to the jump box or using VDI solutions. The point here is that the entry of the device that people are typing their password into, how can you protect that machine? So, yeah. So let's put into perspective. Now, when you have two devices and the same attack happens, when the desktop machine gets compromised, that account is not usable on the privileged access workstation. So that's how the admin privilege gets protected. Earlier, when we talked about when we have this two physical machine deployment for the privileged access workstation, it's a great solution from a security standpoint view. Now you can see how it's protecting the identities. User experience, on the other hand, is a different story. So for the people who are carrying multiple devices, actually I'm going to ask, how many people are carrying two, have their admins carry two devices? A few. So 3? Wow, a few? 4? Anyone? Oh, wow. Anyone for 5? So
that's a whopping 0.4%. Well done. Yeah. We've got to fix this, people. This is a serious attack vector. If we're not convincing you, there are other sessions here that will. I'm sure you've started to see them already, but this really is the attack vector right now. People are stealing credentials. It's been the attack vector for a decade. It's just not something that became apparent until now. The paw projects the credentials as well as the environment into which they're typed in. Really, really critical stuff.
Right. And for the customers that we talk to who are implementing the privileged access workstation using physical machines, and a common feedback that we have heard is that, you know, it's great from a security perspective, my users just don't like it. Why? Because they got to carry more machines, and if they just can't get their work done if one of the machines they need to use is not with them. And that is the very same problems that faced by Microsoft IT. So we have a large user base that are required to use PAW. And multiple devices is just not a solution for us. So this is what we are deploying inside Microsoft IT, where it's a single device solution. The secure access workload runs on the physical device itself. The physical device is very much locked down. So user doesn't have the admin privilege on it. It cannot install any applications as the user wants to, it doesn't have the right. In fact, actually onboarding or allowing an application to be run on a PAW machine requires serious security reviews and looking into the threat analysis. And only after those analysis and then knowing that application meeting these security bars, and then the admin will be putting it on the server so the PAW users will be able to download and install. So it's not a trivial process to actually involving or into any applications into the environment. And each of the PAW solution or the hardware comes with also a desktop as a virtual machine. So now the user has full control of the desktop. So they can do anything they want to inside the desktop to do their email, to do their web browsing, to do their just productivity workload. Internally, we refer the solution as a SAW, Secure Access Workstation. So if you hear people talking about PAW, SAW, it's the same thing. Right now, we have 22,000 users of using this PAW configuration inside Microsoft. So give you an example. Engineers accessing Azure resources, touches Azure customer data, all must be coming from a SAW machine or PAW machine. Also from a Microsoft IT administrative perspective, if anyone wanted to manage production servers, it must be coming from a PAW. And that number keep on growing. There's a key point I wanted to talk about the implementation detail for the PAW infrastructure. It doesn't use the same infrastructure that's used to manage the desktop. It's a complete separate management set of servers and forests, in fact. The reason is that now we want to keep Paul secure so that we have established a separate management infrastructure to lock it down very tightly and heavily monitoring it. And so in this case, if the production server gets compromised, so think of an example of SCCM. If that server gets compromised, and if both of the PAL and desktops are in the same environment, and then the PAL devices can be easily installing some malware onto it. So by keeping them separate, we are now keeping the PAL devices more secure. This is a high level of the topology. On the right-hand side is the production domain servers and services. And the one on the left, labeled as high-risk environment, is the dedicated forest environment for PAL users and devices. This environment has 47 services and replicate globally around the world. And there's a dedicated team to just run this and supporting the PAL users and devices. Microsoft spent millions of dollars to build this HRE environment. All these big investment is trying to provide a good user experience and yet maintaining the security bar, including starting from the provisioning. So let's take a look at how users is actually getting the SAW devices or PAL devices and then use it. This is the engineer that just joined Azure team. The first thing as part of the onboarding, he need to go to a website and say, I'm part of the Azure business group. I need to have access to Azure resources. And that put this user into a special security group and also creating an account in this HRE environment. And that also triggers a request to the OEM to build this PAL machines for this user. So this OEM now have a special image that coming from Microsoft IT and to put on that device. In this building process, and while the device is getting shipped to the user, there's a separate channel. The OEM got to inform the PAL admins, saying that this is the user, this is the device, and this is the TPM information. Why is this separate channel information important? If anything happened to that device during the transports, say the TPM got tampered or got swapped, later on, that device TPM information is not going to match what the admins in the HRE received about the device itself, and that's going to fail the provision later on. Once this device has reached the user, it's going to boot that special image. The first thing that's going to talk to is checking with the HRE about itself, about the integrity. And if it passes and saying, yep, this is a good device, this matches what I received from OEM directly, and now it triggers a OS customization building process. So it starts with always the clean source, which means it's a publicly released Windows 10 operating system image. It's an ISO file. And then it goes through a series customization steps to put all the security configuration into that image. And also, about this user, since he's part of the Azure, there's going to be a set of tools that build into this image for him to use to connect and manage Azure resources. Once that image is being built, inside HRE environment, before it gets downloaded to the device, that image is going to be BitLockered using the TPM information from the device. So that image will be protected during this downloading process. When the image gets deployed actually on the device, that makes the device becoming a PAL device. And that image also comes with a desktop. So user can do their productivity workload in the VMs and then using the PAL to do the Azure management. The user going to log onto the device as a privileged user. If he needs to access the productivity workload, he actually uses his regular domain user to log on. And for this person to access or manage the Azure resources, this device also has a built-in customized VPN client. So the moment the machine starts up, it's going to connect to the VPN in the HRE. And from any network access, this pod device goes through a proxy server. And the proxy server is where we whitelist where this pod device is allowed to go. In this case, he needs to go to manage the Azure resources, and that's on the whitelist, so this user can connect to the Azure resources. All right, let me show you. So, in fact, I have a pod device. This is my very pod device. I've been using it to do the presentation. So in theory, I've been doing the demo all along. This is what it looks like. This is a physical machine. And just using Hyper-V Manager to show you, I have one virtual machine. This is my desktop, which was the one that I used to do my presentation. From the physical machine itself, I use it to manage my Azure resources. But let's see if I want to go to Facebook. Now it's going through the VPN tunnel to the proxy server. It doesn't let me, because it's not on the allowed list. There is
an interesting question. Sorry, Jane.
Yeah.
Do you guys have any idea why MSIT did it this way round? Whereby the privileged access workstation is the hardware, that's the silicon, and yet the workload utilization is down into a VM. Arguably, that seems backwards because the workloads might want to access audio hardware or smart cards, a little more difficult to map into virtual machinery. So why did they do it this way around? I think keyloggers. Somebody else raised a hand here. Precisely. So yours was an example of it. That's the higher level point. Any compromise of the host can make itself and get down into the guest, because a VHDX can be what? Double-clicked on and mounted. We call that the double-click attack. You can literally just double-click on the VHDX. The malware could do that and then infest the privileged access workstation with malware. Hence, they chose to use the hardware for the privileged access workstation to prevent that sort of attack from going back upward. Just thought that was an interesting point to surface.
That's a good call out. In addition to network access, let me show you, I just downloaded a tool here. It's blocked by the group policy. So I don't have admin right on this machine. Actually, let me show you it. I actually don't know the admin right on this machine, and I cannot install any applications that I get downloaded. And everything I need to do as a user that I need to do my research, building my slide deck, everything I did is from these virtual machines. If you're wondering, how is that the same using this virtual machine as a desktop compared to the physical machine? Well, I'm with you. I had my doubt at the beginning. So I've been using this machine for 10 months. At the very beginning, I carried 2 laptops. This one and a backup, a physical machine running my desktop, just in case. If something I cannot use, I have a fallback. But after a period of time, I just got rid of it. Since I was starting to use this machine, I never had a need to take out my backup. So this is actually using virtual machine as a desktop is the starting point how we're building the privileged access workstation. When we show this demo to our customers, and a common request that we've seen is that, OK, how can I get one? And this is where the starting of our PAW project. Our goal is to, well, as a PAW, you need to protect the privilege identities. But most importantly, we don't want everybody, to spend millions of dollars up front, just like we have to do inside Microsoft IT. We want to make it easy and simple to deploy and also can be scalable. carrying multiple devices is just not a scalable solution. Actually, one of the feedback when we talk to our customers, they typically give those physical machines to their very top domain admins because that's the only amount of handful people that they can sort of enforce. Nobody want to carry those many devices. So that's where we started building. There's two aspects in this PAL solution that I'm going to show you. Well, first, just make sure we're all on the same page. It's still early in development stage. It's still a proof of concept. The two aspects that we're designing for, one is about the PAL client itself, how we are going to maintain the security yet provide a good user experience. And then on the other hand is the backend, how we are going to manage this PAL devices using the backend solution, services. And so we have currently two deployment options. One is fully on-prem. So if you wanted to manage everything yourself, the PAL devices, users, images, everything about it, you can do that on-prem. And then the second one is we want to leverage the power of cloud services to help to deploy and manage the PAL devices. So let me start with on the client side, the user experience and this configuration on the physical device. This is what we're building, our current proposal. This is based on the upcoming release in October. We are adding a new feature into Windows client. And then the physical machine itself here, the way we're looking at it is just a hypervisor. We don't want it to run any workload on the physical machine itself. All the workloads going to be pushed into virtual machines. So desktop as a virtual machine, you have seen how Microsoft IT is building it. The new component we're also introducing here is the privileged access workstation as a virtual machine. In fact, it's as a shielded virtual machine. Later, Dean can show you what that means. And this gives the flexibility of locking down even further of the physical hardware, and also providing the flexibility of what customers can create with the PAL virtual machine image. Because everybody have a different environment, right? You got to have your own set of customer tools, and you have your own way of managing. So how we are building some standard PAL VM template images, but if you have customized images you wanted to put in, this model will allow you to be able to do that. So by using separate virtual machines, we're separating the workload, and we're separating the network using different network isolation policies, so they can go to different. For the PAL VM, you can define where the PAL VM can access, and the desktop have the full internet access. And also with the PAL VM, we can now also hardening the OS, just like we did for the physical machine. Obvious benefit, we're going to reduce the cost. It's going to reduce cost since it's a single machine solution. And user doesn't have to carry multiple devices. Everything is in the single device, and they have full access to all the virtual machines. And yet, we still maintain the security boundary here.
I think there's an operational bonus here as well. If you think about the physical machine before, where MSIT have got the paw on the bare metal hardware, what happens if a single individual has to administer more than one high-risk environment, where separate credentials are used in those two environments? Well, how do you do that? Because it's the physical paw. With this model, not only can we create yet more paws by deploying yet more VMs, the means by which you deploy the physical paw is greatly simplified. Because what are you putting on the box? Nothing more than a bare-bones copy of Windows 10 with Hyper-V installed. If you now want to deploy a second or a third paw, what do? Well, Jane's going to walk you through how that's going to be proposed later, but it's effectively a provisioning portal, and it throws a VM at you, which you then run. It's as simple as that. It gives us that infinite extensibility still contained within the silicon of one portable device. You don't have to have 2 or 3 portable devices because you've got 2 or 3 separate, isolated, high-risk environments.
Yep. And so this solution right now here offers all the same benefit that I was showing you about the Microsoft PAL solution. And there is one more. Remote health attestation. How many people are familiar with the shielded virtual machine concept that was introduced in Server 2016?
The rest of you should be ashamed.
This remote health attestation is exactly the same technology that's powering the shielded virtual machine. We are adding that into the upcoming release in the client SKU so that now we can run Paul virtual machine as a shielded virtual machine and get the benefit. Now the hardware, physical hardware, can have the remote health attestation. So for people who are not familiar with it, Dean has a session this afternoon to talk about shielded virtual machines and all the technical details behind the technology itself. But now I'm going to ask Dean to do a 2-minute animation of how this works.
Okay, so this piece is about how we actually attest to the health of a Windows machine. In the past, this was Windows Server 2016 only that we would attest to the health of. Now we can go ahead and do this on Windows 10 Enterprise Edition as well. When it's running Hyper-V, that becomes very handy and very, very relevant to the poor scenario. So the part I wanted to get across here, and this does get into the 300 level, 400 level stuff, so prepare to listen, and I'm going to speak fast. The first thing we use is a TPM. Who knows how TPMs are used for measured boot? Quick show of hands. That's fairly typical, about 10% of you. Basically what we do with a TPM is we use it for a very strong form of immutable identity. It's called an endorsement certificate that lives inside a TPM. It is signed by the vendor of the TPM, and it obviously has a unique asymmetric key pair in there, which we use for identity purposes. It allows the endorsement key public, the EKPub, to leave. That's obviously typical. Public keys are allowed to go out into the world, and the private key remains hidden inside the TPM for its entire life. So we use it for identity. The second thing it's used for is for containing measurements. They have these little things called PCRs, or registers, in which data can be stored. There are lots and lots of different ones. When a machine boots and it uses UEFI secure and measured boot, it takes measurements of every single step along the way. Think of the measurement as like a hash of a binary. I get a 4096-bit hash back, and I shove it into a PCR. I then load the next binary in sequence. I hash that. I add the two together as strings, and I hash them again, getting another 4096-bit. I add that into the PCR, and I continue doing that until I've gotten to the end of the boot path. And what I end up with is a 4096-bit, or whatever it happens to be, depending on what you're hashing, what you're working with, whatever that hash happens to be, but it's a very unique representation of everything that happened on that machine whilst it was booting. If I know that that is a unique hash that represents a safe boot order, I can then use that value in the TPM to seal secrets and say to the TPM, you only release those secrets when that PCR has that value. If that PCR has a different value, no, you do not release the secrets. That is precisely how BitLocker works. We're using it for the same purposes, but we can also use that to measure the health of the machine. Did somebody add malware? Is there a rootkit? Is there a nasty little driver in there that was not part of the blessed whitelist? So basically what we do is, Jane mentioned this, we take that EKPub, the endorsement key of the TPM, and we register it with the host guardian service. That's its identity. Then we take a model machine, that perfect exemplar, the one that you built because you're the trustworthy admin, and it has a perfect operating system with no malware. It's got the anti-malware configured, group policies, everything is on there exactly as you would like. We then use that as a baseline. That gets recorded into something called a TCG log, or Trustworthy Computing Group log file. We upload that along with the EKPub to the host guardian's attestation service. So I now know who the machine is, and I now know what it should look like in terms of a safe boot path with good measurements. Last but not least, we also measure the code integrity policy. You may know of something in Windows 10 and Server 2016 called hypervisor enforced code integrity policy, where we pushed the enforcement point further down, took it out of the kernel, and we can now actually enforce code integrity against drivers. So you can actually cause a machine to blue screen, or green screen in some cases, if the driver does not comply with the code integrity policy. Obviously, you would only do that on the most sensitive of machines where it's preferential for it to fail to boot rather than boot in a secure state. So you have to be careful using those settings. But we measure that as well. What then happens is once we've recorded all those measurements, the shielded virtual machine that is acting as that poor virtual machine, It needs to be decrypted. I'll talk more about what we're decrypting later. But basically, there is a key that is not present on the poor device. It's not there. It's only present on the host guardian service. So here's how it goes. The poor machine boots up, bare bones hypervisor, somebody says, start the poor virtual machine. But it's shielded, so it has a synthetic TPM. Hyper-V needs to decrypt the synthetic TPM, but does not have the key. So it goes to the host guardian service and says, hi, can I have the key to decrypt this privileged access workstation? And the host guardian service, of course, goes, no, you can't have the key. I don't know who you are. Identify yourself. It sends over its EKPub. The host guardian looks that up in a whitelist and it says, yes, that looks good. What we then actually do is we set up a secure channel with the privileged access workstation by making up a symmetric key, encrypting it with the EKPub, and sending it back to the machine. If he hasn't really got that TPM, how the heck is he going to decrypt the key I just sent to him for the secure channel? He has to have the TPM's private key. So we didn't just use it for identity, we used it as a shortcut to establish a secure channel. If that part works, we then say a test, at which point he sends over his TCG log. We compare that TCG log to a known whitelist of goodness, and if it does indeed look good, we say, all right, I know who you are, and you appear to have the TPM that I trust. I know what you said you did when you booted, because you gave me a TCG log, but for all I know, you could be lying your pants off. How can we figure out whether he's lying or not? What we do is we read through the TCG log, and we recompute the values that should exist as measurements in the TPM. And we then go back using our new remote TPM protocol, and we say, give me the values in these PCRs, and send them back across the secure channel, proving that, again, we're talking to the TPM. When we get them over, if the values line up with what we computed, we now know who you are, we now know what you said you did when you booted, and we know that what you said you did wasn't a complete fabrication. Last but not least, we check its code integrity policy. If that lines up, we give it a health certificate that lasts for 8 hours, and we send it over the keying material it needs, encrypted again to virtualization-based security, that little VBS secure runtime that we have on all copies of Windows now. From that point forward, the VTPM trustlet can be, or its state can be decrypted, and up comes the physical access workstation. Ryan and I will talk more about this afternoon, but that is it in about 5 minutes. We'll give you more detail on that later if you're possibly interested, but I don't know how much more detail you care about. Back to Jane.
Great, thank you. That was great.
Thank you.
So just imagine all he said, those benefits, is now as part of the PAL solution. And that's why we are making it into the PAL to make the hardware more secure. So the PAL VM runs in this healthy environment. That's where the PAL VM can start after all those health attestation happens. So here's a highlight of what we are configuring the PAL. We make sure no admin privilege that user gets logged on. We want to whitelist the network where this PAL device can go to. Ideally, actually, now that it doesn't run any workload, so we're actually trying to lock it down such that it only talks to the Azure AD and it only talks to the host guardian service so that it can do its attestation. And then we can lock it down to the application that it can run. Because of, again, no workload, we can lock it down even further. And lastly, the one that remote health attestation that's introduced on the PAL host. And if you're wondering, what are all the security configurations that we are trying to do on the PAL host? Here's a laundry list. I'm going to write this in a document later on and publish it, so you don't really have to memorize everything here. And again, we are also locking down the PAL as a virtual machine, all the security configurations that we're going to enable as a base template that you can start with.
Jane, I think we've got a useful question to ask you. It's only just occurred to me.
Go.
How many of you have got a scenario where a privileged access workstation would need to be used where it may well be disconnected from the host guardian service infrastructure? You can reach that restfully, so you could publish it on the internet if you wanted to. So it is very easily accessible, but are there scenarios that you've got where you would need to do that offline? Need to use a poor VM that requires the host guardian to crack it and boot it up? Are there scenarios for you guys where that would need to be done offline? So a few of you are raising your hands. Not many, I've got 2 or 3. Could I ask those that are raising their hands to come meet me later at the Windows Server Security booth? It's over in the hybrid, what is it called, the hybrid area?
Is Windows Server Security and Identity.
There you go. That's the name of the booth. If you could stop by, I would very much appreciate it, because we'd like to understand what that scenario is, because we're planning to invest in a way of making that happen. And I'd like to talk to those folks that have got real-world scenarios. So the question where was, do we separate the credential between the host logon and the poor logon, or the desktop logon and the poor logon?
Yep. So it depends. So from a poor host perspective, yes, it's a separate identity. And it also depends on how you want to use the PAL VM. The reason I'm saying it all depends is, first of all, it depends on whether you're going to use your on-prem deployment versus the cloud deployment. So that's, if you're using the cloud one, yes, they will be separate, because we are trying to manage the PAL host. And then you will be the admin managing the PAL VMs. So they are separate. The production, the desktop VMs, that's supposed to be the domain users that accessing the productivity workload. That should be a separate identity. Okay. Yeah.
Do you want to get onto the demo, Jen? I'm just worried about time.
And there we go.
Perfect.
So from the PAL host user side of the configuration, I would like to show you where we are in terms of the development. This is a very first PAL that I created using the Azure services, managing and testing against the Azure AGS. Let me switch to that. Come on. Okay. So we had Smart Card Logon configured for, actually it's Windows Hello configured for logging onto the host. This machine is joined to the Azure AD subscription that we created, and also testing against AGS running in Azure. This machine, the host image that comes with the desktop image, just like the Microsoft IT version of the PAL, so user can now already doing their productivity workload on this desktop virtual machine. Right now, it's just a very plain vanilla Windows 10 build, but you can customize it to your corporation need. And when the user gets this PAL machine, and the first thing they will do is to create a PAL VM. That takes about 5 minutes, so I'm going to show you a short video to walk you through that process. This application at the bottom we created is a prototype. The goal is that for the user, don't have to open up the Hyper-V manager, so they can use the simple UI to connect the virtual machines and create virtual machines, and just to look at a couple of aspects of the virtual machines. In this case, the user is going to create a PAL virtual machine that manages Azure resources. So simply, he just needs to define a PAL name, and that's all he needs to, and then specify what roles that he needs to. Again, this PAL VM image can be customized. So in this version, my template is already on the device itself, and we're trying to build, and I'd like to see, hear from your feedback interest to see if you want a cloud service to distribute and manage the PAL VM template as well. So that's it. So after the PAL VM gets created, this is the machine, and this is what I have. So a desktop virtual machine for my productivity workload, and a PAL VM, or Azure Management PAL VM for Azure Management. So first of all, this is what the lockdown experience looks like. I created this PAL VM just to manage, so the experience is like almost like a kiosk mode to run a browser and always connected and only allowed to be connected to Azure Azure resource. This is the hardest part of my demo. like I said. Great, got it. And this is what user will be able to do through this Paul VM and only managing the Azure resources. Currently, we're thinking about building 3 standard VM templates, one to manage Azure resources, and another one to manage O365 resources, and a third one to do RDP to manage on-prem servers. Obviously, there's a lot of other need from different customer perspective, and I'd love to hear your feedback on what you would like to see, and also most interesting part, important part is how that workflow looks like. So we can work out what works and what not works for you. And once it's done, then it only can sign out here. And for any people want to do the productivity workload, this is what's going to look like. Connect to a desktop virtual machine, actually show using a different domain credential, and have all the control and access through this virtual machine, just like I was showing earlier. So here I can do my search. Actually, I can do Facebook, and using my email, or actually using my notes. So if you have feedback later, I'll use this note to capture your feedback in our booth. So we talked about the user client side of the experience, and now I want to talk about a little bit on the back end. We said earlier we want to have 2 options. One is the on-prem solution. Right now we wanted to integrate this as part of the ESAE, Enhanced Security Administration environment. This is a Microsoft consulting services offering where they send people to customer site and help customers to plan and build ESAE environment. And in this process, we are integrating AGS and the latest PAW configuration as part of this service offering. The second one is the Azure services. Right now it's a prototype, early stage. I was showing you that this device is managed by. And this is the one that we would like ask customers to try it out and give us feedback, and we wanted to see how can we make it work for you. Yeah, so I really want to encourage you to try it. Give us a feedback here at the booth or email, and let us build this together. Thank you.